Assalamu alaikum and welcome to MPT channel. Today's topic is International Guideline for Incident Reporting System. It's me, myself, and I, Asad Yusuf, the clinical medical physicist. So, introduction. According to the IAEA safety standard, an incident is defined as any unintended event, including operating error, equipment failure, accident, near misses, or other mishaps, the consequences or potential consequences of which are not negligible from the point of view of protection or safety. So incident learning system, this is how it look like. The first is there is the incident, identification, response, reporting, then investigation, casual analysis, prevention action, learning, and radiation treatment program. So in this way, once the incident was detected, one has to report the incident, then the team will be there for investigation and analyze and try to make a preventive action for the future, share the learning, and it will become the part of the program or policy. The structure of reporting system, there are two types, mandatory or voluntary. Mandatory is primarily used for reporting of actual incidents and not near misses, whereas a volunteer yield much more incident data because near misses are generally requested. Internal event reporting system or reporting inside organization, example, local incident reports. Structure of reporting system, open, anonymous, or confidential. It depends. It varies from organization to organization. So if you want to start this in your system, then of course you have to see what system is eligible for your organization. These are some guidelines of international reporting system. Different institutes or organization has introduced the system, and it's up to you what system you will adopt. This is an HTA guideline, and they define the severity of incident, give the examples, and individual to notify when that incidents occur. There is a Canadian guideline. Again, they also provide with the type of incident, the severity, and with examples. Roses classification. Roses has a very good data. If you visit their website, you will find the data from all over the world. The people used to register, organizations are registered and share their data with them for the learning purposes. Toward the Safer RT UK guideline. So this is a good flow chart to understand if there is an error. First, you have to check whether it's incident or not the incident. So if it is not the incident, then potential for radiation incident, that is a near miss, of course. So this level will be reported. Or there might be a documentation error only, which will not lead any harm to the patient. So it will be other non-conformance level 5. Whereas if it is an incident, then you have to see whether it is reportable or not. If it is reportable, then you have to be level 1, reportable radiation incident. That is 10 to 20% greater overdose or correction is not possible. If it is not reportable, then we have to see whether it is correctable or not. So if it is correctable, then there will be a minor radiation incident. If it is not correctable, then potential or actual clinical significance, this is a level 1. So it is 10% underdose or any overdose which can be compensated. So further explanation of this guideline, the correctable radiation. When an error is detected after only a few fraction, an alteration in the field parameter or the dose delivered can usually be ensured that final treatment delivered to the patient is within tolerance of the intended dose. And this is the beauty of fractionation in radiotherapy. Example of such calculation have been published elsewhere. The incident is called correctable radiation incident. However, if an error is not detected until late in the course of the treatment, complete compensation may not be possible. In such cases, the exact radiobiological consequences of an error can be difficult to establish due to a numerous factors involved. These circumstances, external advice may be sought from the expert in clinical radiobiology. The number of specialists in UK currently offer advice, but the final decision and responsibility as to correct the full course of the action rests with the practitioner who prescribed the treatment. Radiotherapy classified grade is given in the figure point 3. If you go to the towards the RT book, you will find out more detail. So this is a recommendation. Should the decision grid to classify the severity of radiotherapy error, the radiotherapy pathway coding system is given for this book. And these are some examples where you can see the error and then severity. Severity is explained here. So if you implement these kind of guidelines, they give you a guideline how to implement. Saffron guideline is an IAEA guideline, and it's also very comprehensive. And they follow the guideline of Canadian guideline. So that's a similarities there. In AKUH, we are following Saffron guideline, and we have established the policy here. It's been approved from the central command system, the QPSD system here in AKUH. Severity terminologies are different in different organizations. Like IAEA use critical incident, whereas ROSIS uses high risk, WHO use severe, and UK reportable radiation. So the terminology is important to understand, and don't be confused with the different names. It might have the same meanings. So one has to look into that deeply, what they are going to follow. And these are the examples. So the 20% dose variation is supposed to be a critical incident. 10 to 20% is a major incident. According to IAEA, 5 to 10% is serious incident, whereas less than equal to 5% is minor incident in IAEA Saffron guideline. So just a quick look. Radiotherapy procedure includes simulation, voluming, planning, treatment, and verification. And during these processes, there are checks. So in between the volume and planning, there is a clinical review where the doctors sit together and review the volume before moving toward the physicist. Then the planning, and after the planning, physics has a double check system. Then the file goes to the RTT site, and before the treatment, RTT used to check the file. So there is a check system again. Then the treatment, and before the treatment, there are two checks are there, where the timeout and the portal image. Once the portal is approved, then of course treatment will be delivered. And after the treatment delivery, there is a portal verification by the doctor. Later, in weekly review by the physicist, whether radiotherapist or the doctor. And there is also a physics review as well if this policy is implemented in your institute. So summarizing, establish this system in your setup. It's quite important. It helps you to improve. Evaluate the weakest link in the system, and that's the thing it will lead you to. Estimate the risk in your facility. Explain the policy to the staff if it is implemented in your department. Educate them with examples. So with these E's, 5 E's, I'll end my presentation. Thank you for listening.